ang derivatives. Ay, ang hirap. Diyos ko, oh my God. Wait. Nanonood nga ako ng YouTube. Wait. How to get the derivative. Yan. Hi. Yes. Oh my God. Buti na lang merong YouTube. Ito. So next. Ito. Yan dito.
Hi guys! So today we will learn about derivatives and many more. I'm Honey Grace. I'm Angeline. I'm Eros. I'm Ashley. I'm Rizal. I'm Liza. I'm Kat. I'm Danica. I'm Mercy.
I'm Forge. I'm Garb. I'm Richard.
So are you guys ready? Yes!
Good day, everyone. I am Hershika Rayavisa-Grano, and I'm going to discuss the limits and the slope of a second line. But first, let me define what is limit. Limits is if the f of x becomes arbitrarily close to a unique number L as x approaches to c from either side, then the limits of f of x as x approaches to c is L. This is written as limit of f of x equals L as x approaches to c. Take note, if our constant has a negative sign, it is left hand limit. And if it has a positive sign, it is a right hand limit. If there is no sign at all, it is two hand limit. And getting the two hand limit, we must first get the left and the right hand. And if it has if our left and right hand limit is the same, our limit does exist. Example, we were asked to find the value of L. And this is our basis of our answer. We're going to solve for the L. F of x is equals to blank as our x approaches to 2 from the left. So from the left, and the point here, our f of x is equals to 2. Our left hand limit is equals to 2. Next, f of x is equals to blank as x approaches to 2 from the right. So from the right to here is positive 2. Next in line, we're going to solve to find for our two-hand limit, or to find our L, given with f of x equals to blank as x approaches to 2. So since our left and right hand limit are the same, so our L here is 2 and our limit does exist. Hello, it is me again, Hershika Rayavisa-Grano, and as promised, I am going to discuss the slope of a secant line with my friends April Porch, Christian Bubila, and Rachel Ayade. A slope of a secant line is a straight line joining 2 points in a function. It is also equivalent to the average rate of change, or simply the slope between 2 points. A secant line, it is a line that intersects 2 or more points on a curve. Example, here, our line touches the 2 points of the curve, while the tangent line touches only 1. Example, given the equation y equals x squared minus 4x, where our x is equal to 4 and our y is equals to 0. Find the slope of a secant line through the given point. M equals limit of quantity of x plus h squared minus f of x 4 times the quantity of x plus h minus x squared minus 4x. This is our f of x plus h, and here is our f of x, or the given function. Next, we will expand this using the FOIL method. So the answer would be x squared plus 2xh plus h squared. And here, we were going to distribute the negative 4. Negative 4x times x is equals 4x. Negative 4 times h is negative 4h. And copy the function, the given function. Next, cancel the like terms. So next, the answer is 2xh plus h squared minus 4h over h. Next, we are going to factor out the h, since the h is the common here. So put the h outside and put brackets here and cancel the h. So the answer would be 2x plus h minus 4. So we were going to substitute 0 in every h's. So the answer would be limit of x times equals 2x plus 0 minus 4. And the slope would be 2x minus 4.
Find the slope of the second line between x3 and x4. So first, we need to know the given formula. So m equals f of b minus f of a over b minus a. So we all know that f of b is a 3 and then f of a is a 4. So first, find the slope of the second line between x minus 3 and x4. So our line's equation is f of x equals x minus 2 over x minus 5. So the second line slope formula is f of x 0 minus f of x 1. M equal m equals f of x minus f of x1 over x node
Over
minus x1. So now that we know f of 3 equals negative 1/2 and f of 4 equals negative 2. We can plug these values back into our second slope equation, which look like this. So m equals negative 1/2 minus quantity of negative 2 over 3 minus 4. So the answer is m equals negative 1.5. So that is our slope.
Example number 3. The given equation is y is equals to x cubed minus 2x with the coordinates or points of 1 and negative 1, which is the domain is 1 and the range is negative 1. Find the slope of a second line through given point. Slope of a second line is equals to quantity of x plus h cubed minus 2 quantity of x plus h minus quantity of x cubed minus 2x over h. So for us to get the terms that we need is we need to expand these terms. So these are the answer. And distribute the negative to this. And then copy these terms. So the next step for finding the slope of secant line is we need to cancel out the same terms with unlike sign. So these are the And then next step is we need to get the common factor. So the common factor is h. Then cancel out the h. So the answer or the slope of our second line is equals to 3x cubed 3x squared plus 3xh plus h squared minus 2.
So, good day everyone. I am Angeline Coronado and we were going to find the derivatives of a function by using a limit process. So first, let us define what is limit process. Limit process is the value that a function approaches as the input approaches some value. Limits are essential to calculus and are used to define continuity, derivatives, and integrals. So first example is f of x is equals to 6x minus 2. So this we need to find the derivatives using the limit process with this function. So f prime of x is equals to limit, copy the 6. Since there is an x here, we need to put plus h. So copy the negative 2 minus, copy the given which is 6x minus 2 over h as h approaches to 0. Next is limit. We need to distribute this one, which is 6 times x is equals to 6x plus 6 times h is equals to 6h. Copy the negative 2, then distribute the negative sign, which is negative times 6x is equals to negative 6x, and negative times negative 2 is equals to positive 2 over h as h approaches to 0. Next is limit. We need to cancel the unlike terms here, which is 6x and the negative 6x, and the negative 2 and the positive 2. So the remaining is 6h over h as h approaches to 0. So cancel out the h, which is in numerator and in denominator, and the remaining one is 6. So the derivative of this function is f prime of x is equals to 6. So our second example is f of x is equals to x squared minus 7x plus 4. So we need to get the derivatives of this function by using the limit process. So f prime of x is equals to limit and x plus h squared, copy the negative 7. Since there is an x here, we need to put plus h. Copy the plus 4 minus, copy the given which is x squared minus 7x plus 4 over h as h approaches to 0. Next is limit. We need to expand this one since there is a squared here. So x plus h times x plus h is equals to x squared plus 2xh plus h squared. So this answer we need to put here and copy the negative 7. Distribute the negative 7 here. So negative 7 times x is equals to negative 7x minus negative 7 times positive h is equals to negative 7h. Copy the positive 4 minus, distribute the negative here, negative times x squared is equals to negative x squared. Negative times negative 7x is equals to positive 7x. Negative times positive 4 is equals to negative 4 over h as h approaches to 0. Next is limit. So we need to cancel the unlike terms here. Cancel the x squared and the negative x squared. Cancel the negative 7x and the positive 7x. Cancel the negative 4 and cancel the positive 4. And the remaining terms are 2xh plus h squared minus 7h as h over h as h approaches to 0. So next is limit. So in order for us to get the factor of this term, we need to put the every h here. So 2xh is equals to 2x plus h squared. The remaining one is h, and 7h, and the remain into negative 7 over h. Then cancel the h, cancel the h. So equals limit 2x plus h minus 7. Next step is limit. So since there is an h here and h is approaches to 0, we need to change the h here into 0. So 2x plus 0 minus 7 is equals to f prime of x equals 2x minus 7. So this is our final answer. So our third example is the fraction, which is 2 over x. So our given is f of x is equals to 2 over x. We need to get the derivatives of this fraction using the limit process. So f prime of x is equals to limit of 2. Since there is an x here, we need to put plus h. So 2 over quantity of x plus h minus, copy the given, which is 2 over x over h as h approaches to 0. And next is limit. We need to get the LCD of these terms. So x times x plus h divided by 2x plus h is equals to x. Is equals to x. X times 2 is equals to 2x. X times x plus h divided by 2x is equals to negative x plus h. Negative x plus h times negative 2 is equals to negative 2 quantity of x plus h over x times x plus h over h as h approaches to 0. Next is limit negative 2h over x times x plus h. So we need to put a times 1 over h here for us to cancel the h here in the numerator. So cancel the h and cancel the h here in the numerator. Then the remaining terms are is equals to limit negative 2 over x times x plus 0, because h here is equivalent to approaches to 0. So that's why we change the h here into 0. And so our final answer is f prime of x equals, we need to put the negative sign here in the center, and the 2 here, negative 2 over x squared, because cancel this 0, x times x is equals to x squared. So that this is our final answer.
Hello, good day everyone. So my lesson for today is constant rule. The derivative of a constant is 0 and it will always be 0. And that's it. So my example is, I'll show you some of my examples. So example number 1 is f of x is equals to 7. F prime of x is equals to derivative of 7. Since there's no variable, the answer is 0. That's why. And so example number 2 is f of x is equals to 16 over 47. F prime of x is equals to derivative of 16 over 47. Since there's no variable, the answer is 0. And the last example is f of x is equals to 68.5. F prime of x is equals to 68.5. F prime of x is equals to derivative of 68.5. Since there's no variable, the answer is 0. And that's all. Thank you.
So now, our topic today is power rule. Power rule is the given function is defined by f of x equals to the power of n, where n is any non-zero constant and x is not equal of 0 for any given n. So example number 1, f of x equals to x to the power of 3. So the derivative of x to the power of 3 equals to f prime of x equals to d over derivative of x equals to x to the power of 3. F prime of x equals, bring down the 3, so 3x to the power of 3 minus 1. Kailangan talaga i-minus natin ng 1. Constant na yan. So, f prime of x equals to 3x. 3 minus y equals to 2. So, 3x to the power of 2, that's the final answer. So, example number 2. F of x equals to x to the power of 4 over 3. So, f prime of x equals to, bring down the 4 over 3 is 4 over 3 times 4 over 3 minus 1. So, the final answer is f prime of x equals to 4 over 3 times 1/3. 4 over 3 minus 1 equals to 1/3. So, example number 3. F of x equals to x to the power of negative 4. Bring down the negative 4, so f prime of x equals to negative 4. 4x to the power of negative 4 minus 1. Negative 4 minus y equals to negative 5. So, f prime of x equals to negative 4 times x to the power of negative 5.
Good day, everyone. I am Eros Pantoja, and I am here today to tackle about sum and or difference. So first, let me tell you what is the sum and or difference. The sum and or difference rules tell us how to take derivatives of functions that have more than a single term. They are some of the most frequently used rules, so much so that we tend to use them automatically without even realizing it. So, in order to get the answer by using the sum and or difference, simply put the derivative of a sum or difference is equal to derivatives. More precisely, suppose f and g are functions that are differentiable in a particular interval a, b. Then, the sum f plus g and the difference of f minus g are both differentiable in interval. So I have here the first given example, which is f of x is equal to x cubed minus 8x plus 4. So what have I said earlier? We have to follow the differentiation rule. So we are now going to proceed. So here, this is the first process in order to get the answer of this given example. We have to distribute each term because so the differentiation rule said that the exponent is that we have to put this beside and then put minus 1 here, so it is equal to squared minus 8x1 minus 1 is equal to 8 plus. So since we are now done by following the differentiation rule, which is we have to subtract the exponent to 1. So we have 3x squared minus 8x plus 0. So this the 4 became 0 because we are following the constant rule. So if the number is constant, then we have to transform it to 0. We are now going to proceed to the final answer. So, this is now the final answer. For number 2, since the given problem is a polynomial, then if we will follow the differentiation rule, which is we need to combine the 3 other rules, which is the constant rule, the power rule, and the constant function, and of course our target, the sum and or difference. So just like the first example, we have to distribute each term by following the differentiation rule. So we have to transfer the exponent to beside the 7. So after doing that, we have to simply times each, and then so kailangan nating ibaba ang exponent na 5 sa tabi ng 7. And then do the same thing to the rest. After that, we are now going to multiply 5 times 7. So 5 times 7 is equal to 35. And then kailangan natin kunin kung ilan ang makukuha natin pag ating sinubtract si 5 sa 1. So ito na ay nagiging 4 plus 2 times 3 is equal 6. And then dahil 1 na siya, hindi na natin to lalagyan ng exponent. At ito ay so ito na ngayon ang ating final na answer, which is f of x is equal to 35x to the 4th power plus 6x minus 4. So the last example is the difficult part. Since the given have a rational expression and a radical sign, we have to form it first to exponential form. So by getting the exponential form, we have to separate each numerator and denominator. So kapag sineparate natin ang dalawa, ang denominator at numerator ay may 1 na nakalagay. Ito ay magiging 1 over x raised to the 4th power times 2 over 1. So 1x raised to the 4th power times 2 over 1 is equal to x raised to the negative 4 times 2. So kaya naging negative sign ang exponent ng x to the raised 4th power dahil ito ay ating in-inverse. So x raised to the negative 4th power times 2 is equal to 2x minus 2x raised to the negative 4th power. So nakuha na natin yung exponential form ng rational expression. So ngayon, kukunin na naman natin ang exponential form ng radical sign na 1 over the square root of x. So 1 over the square root of x is equal to 1 over x raised to 1/2. So kagaya na sinabi ko kanina, kailangan natin i-inverse para maging exponential form. So ngayon, ito ay magiging x raised to the negative 1/2. So ngayong nakuha na natin ang exponential form ng dalawa, kailangan na nating we have to proceed to the next process dahil nakuha na natin at naging exponential form na sila. So 2x raised to the negative 4th power is equal to 2 times negative 4 times negative 4 minus 1 plus x raised to the negative 1/2 plus 2. Negative 1/2 x raised to the 1/2 minus 1 plus 2. So, ngayong na-distribute na natin ang each term, kailangan na natin kunin kung ilan yung makukuha natin pag kinuha na natin sila. So, 2 times negative 4 is equal to negative 8. Then negative 4 minus 1 is equal to negative 5. Minus negative 1/2 x. So x negative 1/2 is equal to negative 1/2 x raised to the negative 1/2 minus 1 plus 2. So kailangan natin tong So negative 1/2 minus 1 is equal to negative 3 over 2 plus 0. Dahil yung to ay constant na, kaya nagiging 0 ito. So, pagkatapos nun ay makukuha na natin ang final na answer, which is negative 8 over x to the raised to the So ngayong nakuha na natin ang final answer, which is negative 8 over x raised to the fifth power minus 1 over 2 over raised to the 3 over 2 power. Final na answer.
So today we're going to talk about the product rules. What is product rules? The product rule is used when differentiating two functions that are being multiplied together. So here are the examples of the product rules. F of x is equals x raised to the power of 4. So the derivative of x raised to the power of 4 is 4x raised to the power of 4 minus 1. So the final answer is 4x cubed. The second example is f of x is equals to 3x squared. So 3x squared, 3x derivative of x squared is 3 times 2x raised to the power of 2 minus 1. So 3 times 2 is 6. 2 minus 1 is 1. So 6x is the final answer. So we are going to get the product of these functions. So y is equals to x raised to the power of 1/2. So the derivative of x raised to the power of 1/2 is 1/2 times x raised to the power of 1/2 minus 1. So 1/2 times, we are going to transpose this since it is negative. So 1/2 times 1 over x raised to the power of 1/2. So 1/2 times 1 over square root of x. So the final answer is 1 over 2 square root of x.
The next rule is quotient rule, which states that the derivatives of h of x is equals to f of x over g of x, which are both functions of x. So we got the h prime of x equals to v du minus u dv over v squared. So example number 1. H of x is equals to 1 over x. First, we must get the derivatives of u and v. So ru is equals to 1 and the derivative of u is equals to 0. And rv is equals to x and its derivative is equals to 1. So we must substitute h prime of x is equals to x times 0 minus 1 times 1 over x squared. So h prime of x is equals to 0 minus 1 over x squared. So when we minus 0 and 1, we got 1, negative 1. So h prime of x is equals negative 1 over x squared. So the next example is f of x equals 1 over 2x plus 1. Like what I've said, we must get the derivatives of u and v. So ru is equals to 1 and its derivative is 0. And rv is equals to 2x plus 1 and its derivative is equals to 2. So substitute f prime of x is equals to 2x plus 1 times 0 minus 1 times 2 over 2x plus 1 squared. So when we multiply 2x plus 1 to 0, we got 0. And when we multiply 1 and 2, so we got negative 2 since it is negative. So f prime of x is equals to 0 minus 2 over 2x plus 1 squared. So since it is negative, we minus 0 from negative 2, we got f prime of x equals negative 2 over 2x plus 1 squared. So that's the answer. So the next example is f of x is equals to 2x plus 3 over 3x minus 1. Like what I've said earlier, we must get the derivative of u and v. So ru is equals to 2x plus 3 and its derivative is 2. And the rv is equals to 3x minus 5 and its derivative is 3. So we must substitute f prime of x is equals to 3x minus 5 times 2 minus 2x plus 3 times 3 over 3x plus 5 squared. So when we multiply 3x and 2, we got 6x. And when we multiply negative 5 and 2, we got negative 10. And then here, we got, we must multiply 3 and 2x, so we got 6x. And then 3 times 3 is equals to 9. And then, since there is a symbol of negative, so we must distribute. So 6x, negative 6x and negative 9 over 3x plus minus 5 squared. So we must combine like terms since 6x and negative 6x have this different sign, we must cancel. So we got 9, so we got 9 and negative 10 plus negative 9 is equals to negative 19. So we got f prime of x is equals to negative 19 over 3x minus 5 squared. That's all. Chain rule. The chain rule states that the derivative of f of g of x is f prime of g of x times g prime of x. So example number 1. Y equals to 13x plus 15 to the power of 3. So the 3 here will be ay mapunta dito. So y prime equals to 3 times quantity of 13x plus 15 to the power of 3 minus 1. So times the g prime of x. The g prime of x is, the g is 13x plus 15. So derivative of 13x plus 15. So y prime is equals to 13 times quantity of 13x plus 5 to the power of 2 times 13. 13 times 3 equals to 36. So the answer is y prime equals to 36 times quantity of 13x plus 5 to the power of 2. Example number 2. H of x was the square root of 11x to the power of 2 plus 15. So because it is a radical, let's change this into an exponential form. So h of x equals to prime of 11x squared plus 15 to the power of 1/2. So now we can apply the chain rule. So f prime of x equals to 1/2 times prime of 11x squared plus 15 to the power of 1/2 minus 1 times derivative of a g, which is 11x squared plus 15. So h prime of x was 1/2 times 11x plus 15 to the power of negative 1/2 times the derivative of this 11x squared plus 15 equals to 22x. So h prime of x equals to 22 times 1 equals to 22x times prime quantity of 11x plus 15 to the power of negative 1/2 over 2. So h prime of x equals to 22x. Because it is a negative, let's transpose this into denominator. So it will become 22x over quantity of 11x plus 15 to the power of 1/2. 1/2, because it is a 1/2, we can change this into a radical sign. So the final answer is h prime of x equals to 22x over square root of 11x plus 15. Example number 3 is f of x equals to 1 over quantity of 2x squared plus 4 to the power of 3. So we can change this into exponential form. F of x equals to 2x squared plus 4 to the power of negative 3. So we can apply the chain rule. So f prime of x equals to negative 3 times quantity of 2x squared plus 4 minus 3 minus 1 times derivative of g, which is 2x squared plus 4. F prime of x equals to negative 3 times quantity of 2x squared plus 4. Negative 3 minus 1 equals to negative 4 times derivative of 2x squared plus 4 is 4x. So f prime of x equals to negative 12x times quantity of 2x squared plus 4 to the power of negative 4. Because it is a negative 4, let's transpose this. So f prime of x equals to negative 12x over quantity of 2x squared plus 4 to the power of 4. Hello guys! At alam natin ang limang differentiation rule, we are going to go over the derivatives of trigonometric functions. At there are 6 of them na kailangan mo malaman. So, let's take it this first. These are the 6 trigonometric functions na nakaderivative na. We have the derivative of sin x is equal to cosine x. And the derivative of the cosine x is equal to negative sine x. Now, look at the pattern. As I stated, so we have the derivative of tangent x is equal to secant squared x. And the derivative of cotangent x is equal to negative cosecant squared x. And then the derivative of secant x is equal to secant x tangent x. And the derivative of cosecant x is equal to negative cosecant x cotangent x. At dahil nalaman niyo ang pattern, tingnan niyo na mabuti. Sa may right side nyo, makikita nyo dito na lahat ng c's ay may negative sign. At sa left side naman, makikita nyo dito na lahat ay positive. So, kailangan nyo lang itong i-memorize para makuha ninyo ang mga iba't ibang kailangan natin gawin pa kung may trigonometry man siya. So, example. Example number 1. Find the derivative of 2 cotangent x minus 7 cosecant x. So, since it has the two terms, so ang makikita nyo rito na whole number ito, so papalabasin natin yung 2 rito. So, we have 2 derivative of cotangent x minus 7 derivative of cosecant x equals, hahanapin natin ang derivative ng cotangent x. Makikita nyo rito na ang cotangent x is equals to negative cosecant squared x. So, minus 7 derivative of cosecant x is equals to negative cosecant x cotangent x. So, 2 times the derivative cosecant x is equal to negative cosecant squared x minus 7. The derivative of cosecant x is equals to negative cosecant x cotangent x. And then, let us distribute. We have 2 times the negative of cosecant squared x is equals to negative 2 cosecant squared x. And negative 7 times negative cosecant x cotangent x is equals to, since it is a negative and times negative, we are going to change it into positive. So the result will be negative 2 secant squared x plus 7 cosecant x cotangent x, and that is the final answer. Our example number 2 is y is equals to negative cotangent x minus 2 times the cosecant x. Sunod natin hahanapin natin ang derivative ng dalawang terms. But, this is the first term, second term, and the third term. As you can see here, dalawa sila rito. So, kailangan natin hanapin ang derivatives. Ito. Since 2 at cosine x ay dalawang term, kailangan natin gagamitin ang product rule. So, alam na natin kung paano ang product rule. So, hanapin lang natin ang f of x at ang g of x. So, ito yung f of x natin. 2 is our f of x, and cosecant x is our g of x. So, f of x is equals to 2, and g of x is equals to cosine x. F, the derivative of f of x is equals to 0. Since 2 is constant, 0 ang labasan nito. Sunod, hanapin natin ang derivative ng g of x. So, g prime of x is equals to cosine x is equals to negative sine x. Sunod natin gagawin, hanapin natin ang derivative nito by using the product rule. So, we have the product rule f of x times the g prime of x plus the g of x times the derivative of f of x. So, i-substitute lang natin. So, ang f of x natin is 2. At ang derivative ng g of x is negative sine x times negative sine x plus the g of x is cosine x times the derivative of f of x is 0. So, we have the result. Ang derivative na ito ay 2 times negative sine x is equals to negative 2 sine x. And then, cosine x times 0 is equals to 0. So, ito na ang derivative sa part na ito. Hanapin na natin yung ang derivative din nito at ito. So, alam na natin ang derivative nito. So, we have y prime is equals to the derivative of d of x negative cotangent x minus ang derivative na kuha kanina is negative 2 sine of x. Sunod, hahanapin natin ang derivative ng negative cotangent. So, ang derivative ng negative cotangent is equals to negative cosecant squared x. So, we have y prime is equals to negative, the derivative cotangent x is equals to negative cosecant squared x. Sunod, negative times negative is equals to positive. And then just copy it, we have 2 sine of x. Sunod, since prime of y prime of is equals to negative times negative is equals to positive. So, di lang natin yung lalagyan. So, we have cosecant squared x plus 2 sine of x. At ito, ang nakuha sa derivative na ito. So, our next example is f of x is equals to secant x over cotangent x. In order for us to get the derivative of this term, we are going to use the quotient rule. Let's first find the f of x and the g of x. This is our f of x. And this is our g of x. So, we have secant of x and cotangent x. Find the derivative of this term and this term. So, f prime of x is equals to the secant x is equals to secant x tangent x and tangent x. And the derivative of this term is g prime of x is equals to the derivative of cotangent x is equals to negative cosecant squared x. And then, since we already identified the f of x and the g of x, we are going to use the formula of the quotient rule. The formula is g of x times the f prime of x minus f prime of x times the derivative of g of x over g of x squared. Then, going to substitute, g of x is cotangent x. And the derivative of f of x is secant x tangent x minus the derivative of f of x is secant is the f of x is equals to secant x times the derivative of g of x is negative cosecant squared x. Then we are going to simplify. We have h of x is equals to cotangent x times secant x tangent x is equals to cotangent x secant x tangent x. Next, negative secant x times negative cosecant squared x is equals to positive secant x and cosecant squared x. So, that is our final answer. Since we are finding the derivative of this term, so this will be f of x. That is the final answer.
So today we are going to discuss the higher order derivatives. So let the function y equals to f of x have a finite derivative f prime of x in a certain interval. So we're going to tackle about the example number 1. So the function is f prime of x is equals to 4x raised to the power of 6 plus 3x raised to the power of 4 minus 6x plus 4. So we're going to get the second derivative of this function. So the derivative of x raised to the power of 6 is 6x raised to the power of 5. So the derivative of x raised to the power of 4 is 4x cubed. So the derivative of 6x is 1 plus 0, which is the constant number 4. So the first higher order derivative is 24x raised to the power of 5 plus 12 cube x cubed minus 6x. So in order for us to get the derivatives of these, we're going to differentiate to get the second derivative. So 24 times 5 is 96. So 12 times 3 is 36. So the final answer is 96x raised to the power of 4 plus 36x. So let's proceed to the example number 2. F of x is equals to 4x raised to the power of 5 plus 3x raised to the power of 4 minus 6x plus 2. So we're going to get the third derivative of this function. So the first derivative of this function is 20x raised to the power of 4 plus 12x cubed minus 6x plus 0. The second derivative is 80x cubed plus 30x squared plus 0. So let's proceed to the third derivative. So the third derivative is 240x squared plus 72x. So that is the final answer. Let us proceed to the example number 3. So the function is f of x equals to 5x raised to the power of 5 plus 3x raised to the power of 4 plus 6x raised to 6x cubed plus 2x squared plus x plus 1. So the first derivative is 25x raised to the power of 4 plus 12x cubed plus 18x squared plus 14x plus 1, which is the x, plus 0, which is the 1 constant. So let's get the second derivative. F prime of x,
Stop. Ay, pause. Ay, ako record. Dali.
Nakalimot ko kani.
Sige.
Nalimutan ko na po. So, wag na. So, example number 3 is we're going to get the fourth derivative of this function. The function is f of x equals to 5x raised to the power of 5 plus 3x raised to the power of 4 plus 6x cubed plus 2x squared plus x plus 1. So we're going to get the first derivative. So 25x raised to the power of 4 plus 12x cubed plus 18x squared plus 14x plus 1 plus 0. So let's proceed to get the second derivative. So the second derivative is 100x cubed plus 30x squared plus 36x plus 4. Let's proceed to third derivative. So 300x squared plus 72x plus 36. So we're going to get the derivatives of this using differentiating it. So 600x plus 72 is the final answer.
We already know the background of high order derivatives, and now we will proceed to application of higher orders. So first problem. Jerry, an average worker, arrives on the job at 9 a.m. Will have produced G of R is equals to R cubed minus 4R squared plus 12R units R later. A. Compute the worker's rate of production at 12 p.m. So 9 a.m. as respect of time is equals to 0. That starts initially. Then 12 p.m. is equals to 3. Thus, G prime of R is equals to 3R squared minus 8R plus 12. Next is to substitute the R with the respect of time, which is 3. So it would be 3 times 3 to the power of 2 minus 8 times 3 plus 12 equals 69 units per hour. Next, B. Find the rate of the workers' rate of production at 12 p.m. First things first, we need to put some attention to the repeated words. Here, rate and the workers' rate. So, it means that we need to find its second prime of G, second prime R is equals to 6R minus 8 using this first equation above, second equation above. So, next, we need to substitute it by 3. It would be 6 times 3 minus 8. Then is equals to 10 units per hour per hour. Second equation. The factory can reduce n of n is equals to 3m to the power of 4 plus 4m cubed plus 2m squared plus 5m units of product from 6 a.m. to 11 a.m. Find the rate of the factory's rate of production at 11 a.m. So first things first, we need to find the derivatives of the given equation. So the derivative would be 12m cubed plus 12m squared plus 4m plus 5. Next, we need, but before all of this, we should give attention to the repeated words from what I had said earlier. So in this case, we have the rate of the factory's rate. So it means that we need to find the n prime of m. So as we already have the n prime of m, next we need to proceed to n prime of m. So it will be 36m squared plus 24m plus 4. Next is n third prime of m is equals to 72m plus 34. Next, we need to substitute it by 5. Where did we get that number 5? It is from 6 a.m. to 11 a.m. So 72 times 5 plus 24 is equals to 384 units per hour per hour per hour. And now we will proceed to the given number 3. Given x is equals to y squared minus 2y and dy over dt is equals to 3. Determine the change of the variable when y is equals to 4. But in this equation, we don't need to find the x since there are no terms containing x in the given equation. So x prime is equals to 2y minus 2. We just need to find the derivative of the given equation. Next, dx over dt as y is equals to 4. So, we need to use this equation to here. So, we need to substitute y by 4. So, 2 times 4, then minus 2. But, before all of that, before we compute the final answer, we need to multiply it by 3. Where did we get this number 3? So, we did get this number 3 from here. In respect of dy over dt is equals to 3. So, 2 times 4 is equals to 8 times 3, 24, minus 2 times 3, 6. So, we have 18 as the final answer.
My name is Kat, and now we're going to talk about optimization. In optimization problems, we are looking for the largest value or the smallest value that the function can take. So we have here example number 1. Find two positive numbers whose sum is 300 and whose product is a maximum. First things first is in optimization, there are two equations in the optimization, the constraint and optimization. The optimization in this problem is that we are finding its maximum. So we have here maximum. The maximum is A is equals to x plus y. It is because we are finding its product. And we have here x times y. Next is constraint. Constraint is the equation that it must be absolutely or positively true in any equation. So we have here x plus y is equals to 300. And now for the solution, we will use first the constraint equation. 300 is equals to x plus y. And to get the y is we have to add each sides by, we have to minus each sides by negative x. So 300 minus x is equal to x minus x plus y. Then x minus y is 0, so cancel that. We're left with 300 minus x is equals to y. Next, for the product, we will use the maximum equation. A minus a is equals to x times y. Then we will substitute the y here to the y in the product equation. So we have a is equals to x times 300 minus x. Next is to distribute x to this equation. 300 x minus x squared. After that is to get the derivative of this. So we have 300 minus 2x. And now we're going to find the value of x and y. And for the x, we will use the derivative, which is 300 minus 2x. So to get the x, we will add each side by positive 2. So we are left with 300 and 2x. Next is we will divide this each terms by 2. So 300 divided by 2 is 150, then 2x divided by 2 is x. So our x is 150. And now for the y, to get the y, we will use the function from the sum. So in the y, we will substitute its x by the x we got here. So 300 minus x, which is 150, is equals to 150. And now for the next example is let x and y be two positive numbers such that x plus 2y is equals to 50, and the quantity of x plus 1 times the quantity of y plus 2 is a maximum. And now we have these two equations to use. For the constraint is x plus 2y is equals to 50, and for the maximum is f is equal to the quantity of x plus 1 times the quantity of y plus 2. And now to start, we will use the equation for constraint to find the value of x. So now x plus 2y is equals to 50. To get the value of x is that we will minus each side by 2y. So we are left with x is equal to 50 minus 2y. And now for the next step is we will use the maximum equation, then substitute the x from the constraint, and now we have 50 minus 2y plus 1 times y plus 2. Then 50 plus 1 is 51, then copy the negative 2y times y plus 2. Next is we will FOIL these functions, then we're left with 102 plus 47y minus 2y squared. Then after that we will derive this function. And to derive, we are left with 47 minus 4y. And now we will answer for the y. To find the y, we will use the equation from our derivative. Then we will add each side by 4y. 47 minus 4y plus 4y is equals to 4y. Then this is equal to 0, so 47, then 4y. After that, we will divide each terms by 4. So 47 divided by 4, then 4y divided by 4 is y. So our y is 47 over 4. Next, for our x, we will use equation from the constraint. So 50 minus 2, then substitute dy, 47 divided by over 4. So we will distribute negative 2 to the 47 over 4. Then our x now is 53 over 2. Next is for the sample number 3. We need to enclose a rectangular field with a fence. We have 500 feet of fencing material and a building is on one side of the field, and so won't need any fencing. Determine the dimensions of the field that will enclose the largest area. So now we have here an illustration for the building and for the fences. We have there the two equations for the area. A is equal to x plus x times y, and the perimeter, which is 500 feet, is equal to x plus 2y. 2y because this side here is equal to this side here, so y plus y is equal to 2y. Next is we will use the perimeter for the perimeter equation, and to get the value of x, we will minus each side by negative 2, so we are left with 500 feet minus 2y is equals to x. Next, for the area, we will use the equation and substitute the x from the value here. Then 500 minus 2y times y. We will distribute the y to this equation, so 500y minus 2y squared. Next is to get its derivative. Its derivative is 500 minus 4y. Next, for the for y, we will use the derivative. And to get the y, we will add each side by positive 4. So we are left with 500 and is equal to 4y. Next is we will divide each terms by 4. So 500 divided by 4 is 125, and 4y divided by 4 is equal to y. So we have now our y. Next is we'll find its x. So in x, we will use the equation we get here from the x. Then we will substitute the y from the y we get here. So x is equal to 500 minus 2 times 125. So 2 times negative 2 times 125. 500 minus 2 times 125 is 250. So our x is 250 and the y is 125.
Hi guys! Again, thank you for watching our video.
We hope that you've learned a lot from this video.
Please like and subscribe down below and click the notification bell for more videos. Thank you! Bye!
Ganito pala makuha yung answer. Okay. Dali lang. Wait.